Good morning all. Today we are going to discuss the topic protection and deprotection of the functional group. Now, the important thing, why there is a need of protecting this group or functional groups. So, in case of multifunctional compounds, that means when there are more than one functional groups are present, at that time the reactivity of one functional group increased by protecting other group. That means one group get protected to make other one more reactive. And for protecting different functional group, there are different methods we use for protecting functional groups. And there are some requirements of these protecting groups, and these are: the protecting group reagent must react selectively in gradient. That means the protecting groups are very much selectively react, and the protecting group must be selectively removed in gradient to readily available reagent. So the protecting group selectively removed, and third one is the protecting group should not have additional functionality, because if there is additional functionality on the protecting group, it is liable to react on that other side also. So these are the requirements of protecting group. Now, for example, suppose if this type of compound, this type of multifunctional compound is there. This compound contains two functional groups. One is ester and another one is this carbonyl keto group. Okay. Now, suppose this compound is treated or reacted in presence of LiLH4, that means lithium aluminum hydride, then we know that both the functional group undergoes reduction to give alcohols. But suppose if we want to reduce only the ester group in presence of this carbonyl group, then at that time there is a need of protection to this carbonyl group, keto group. So any method can be used for protecting this carbonyl group. Suppose we can protect it by making acetal of this ketone, and then reaction carried out only at the ester functional group to give alcohol. Okay, so this is the reason why we protect functional group in multifunctional compounds. Now, moving towards our next topic, that is protection. Today we see the protection of amines. Amines, that means primary amines as well as secondary amines. These primary and secondary amines, these both are very prone to the oxidation, to metallization. That means they are very reactive to organometallic compounds, and that's why there is a need to protect these amines before performing any type of substitution reaction in difunctional compounds or multifunctional compounds. So there are so many methods, but one of the methods by which we can protect these amines is by converting them to amide. We will convert amine into amides to protect them, into carbamates. We can convert them to carbamates to protect them. Or here we can also use the BOC, that is tertiary butoxy carbonyl group. So these three methods are used to protect the primary as well as the secondary amine to get the desired product. So first of all, we see how these amino groups or amines are protected. So before going to in details, we see that if amine contains such type of benzyl group in primary or secondary amine, if this type of benzyl, which is also equivalent to this, that means it is also written as BN, where BN is the benzyl group here. If such type of benzyl group are present in the amines, Then these benzyl group are very much resistant to organometallic compounds. Then these type of compounds are used to expose the organometallic compounds or metal hydrides. So suppose if the amines, we consider here a primary amine or a secondary amine, these may also undergo such type of reaction. Here I am using BnBr, that means benzyl bromide, in presence of this amine, tertiary amine and methyl cyanide to give this type of product. Here Bn is benzyl group. Okay. Again, if we do reaction on this secondary amine, we can also use BnCl in presence of NaH, and THF is used as a solvent. In this condition, the two groups are substituted, or this hydrogen gets substituted by the Bn. So in this Bn are very much resistant to organometallic reagents, and we can easily perform the reaction on this side, easily. To recover this products, we can use here PD, palladium on carbon. That means this is a reduction used or can be performed by using PD over carbon, and in this case we can get our recovered product like this. Okay. So here we got our initial product after reaction. So this is the protection and deprotection. This is such type of compounds are very much useful when benzyl group is present in your amines groups. Okay. So after this, one more thing is here. One example we can take here is, suppose the amines contain such type of functionality here. Okay. What is here? One end of this compound attached with OBN, means this ether linkage is there. In this case, we can treat this compound with 20% palladium hydroxide in presence of our based on the carbon as a catalyst, and H2. Here H2 gas is used and solvent is ethanol. Okay, so in this condition, this compound is recovered. Your amine is recovered to give this product, this desired product. The compound is recovered. This reagent is also called as the Perlman, PEAR, Perlman reagent. This reagent is also called as the Perlman reagent. The 20% vanadium hydroxide based on the carbon as a catalyst. Okay, so after this we will continue with our topic, and we will prepare amines from this amine groups. Okay, now preparation of amines. Now we know that the amides are prepared from amines by acylation. Okay. Now why there is a need to convert them into amides? Because in amines, basicity of nitrogen, in amine, the basicity of nitrogen is reduced by making them less susceptible to attack by electrophilic reagents. That means if we convert this amine into amide group, this nitrogen is now less susceptible to the electrophilic attack. Now how? Because this lone pair on nitrogen can also be written. That means if we take here the lone pair, what is okay, so this bond opens here and the compound got double bond NH2. So because of this, the lone pair of the nitrogen is less available and the basicity decreases. Now the main reason for the basicity of nitrogen in amines is its lone pair. This lone pair on nitrogen is easily protonated to any electrophile, and because of this basic nature, they are very, very reactive, and we have to reduce this. So we can convert this amine into the amines. The reaction is all of you know that the amines are converted into amide either by using this acetic anhydride or the acetyl chloride, and here the amide is formed. Okay. Now this amide in presence of H positive, or OH negative can be deprotected. We can do the deprotection of this amine by using this strong acid. Generally 6 normal axial is used for deprotecting this amide group into amine. So this is the reaction for this. Okay. Now after protecting, these two sides are easily available for doing different types of substitution reaction, different reaction here, and the reaction is carried out in presence of either these reagent and deprotected in presence of strong acid. Okay, so these are the amides, which is one of the methods of protecting amines. The second method which we are going to discuss here are carbamates. Now, what are these carbamates? Carbamates are this type of compound. Okay. Amino group is attached here, and this one is the ester functionality. These type of compounds are carbamides, which behaves like amide, and they no longer act as a nucleophile. Okay, they behave like amides, and that's why they do not act as a nucleophile so longer. These compounds are stable to oxidizing reagents and aqueous bases, but may react with reducing agents. Sometimes they may react with the reducing agents. Now see how these compounds are prepared. Suppose if amines are there, primary amine, this type of compound, this type of chloroesters are used in presence of K2CO3, your potassium carbonate, or we can use ET3, and that means your triethylamide here to form such type of substituted product. This is carbamate. Now this side is available for the reaction. We can perform any reaction at this side, and for the deprotection, here iodo-trimethylsilyl groups is used. Iodo-trimethylsilyl group is used, and the solvent is chloroform or carbon tetrachloride. And here again we get our amines. Okay, so this is about the carbamates. We can take one more example. If the compound contains such type of amides, or we can say that amines, secondary amines. So in such case also there is carbamates can be prepared, which can be deprotected by using the H2PD. So we'll take this reaction. Now here I am using BN group for this chloroether compound, BNOCl compounds for protecting this. Then here other solvent, we can also write here the solvent. Now this group, amino group, get protected here. N group get protected. Okay, and after that here we can write CO2s. Okay. Now this group or all these positions are free for further reaction. We can perform any reaction on other side because the reactive amino group get protected by using this carbamide, and now further this can be deprotected by using H2PD. By using H2PD, your compound gets recovered. Okay, so this is also one of the example we can try for under carbamates. This is the second method for protecting amines. Now the third method by which we can protect amine is by using DOC. Now what is this DOC? This DOC is tertiary butoxycarbonyl compound. Tertiary butoxycarbonyl compound. This tertiary butoxycarbonyl compound is inert to hydrogenolysis and resistance to bases and nucleophilic reagent. And they are cleaved by strong acid. Means for deprotection, here we can use strong acid like trifluorocarboxylic acid and all. Or we can use AlCl3 for its deprotection. So what is DOC? DOC is the tertiary butoxycarbonyl group which is used for protecting amine to get the. Now we will take the one example for protection of amines by using this DOC. This compound which is difunctional compound. Yes, here the amino group is here. Or we can attach it here as more. Okay, so this type of compound, it can be protected by using this reagent BOC2. Now, what is this BOC2? We know that this is a tertiary group, tertiary butyl group. So this compound is like this. Tertiary butyl groups are here. Okay. So this reagent we are using here for protecting this amino group, this NH2 group here. And after protection, this compound is like this. Okay, this is a tertiary butyl group. Now, this amino group is get protected, and the other sides of the this compound are available for different reactions. And for the deprotection of this compound, what we get here, we also got here the tertiary butyl alcohol and the CO2 are formed with this compound. We can deprotect this compound by using a strong acid. I already told that. Here we use strong acid like trifluorocarboxylic acid and or AlCl3 also. After deprotection, your amino group is recovered and the desired compound is obtained. Okay, so this is about the DOC, that is tertiary butoxycarbonyl group, which is useful for protecting amino group. Now with this final product, here we got acid, this type of alkene substituted and CO2 are obtained. So these are the three methods by which we can protect amines and to carry out different reactions, and then again they are deprotected. Okay, thank you.